Welcome. My name is Jared Golpe Rivabarco. My my number of control is 18481263. I'm from the campus of ITNL in Guadalupe, Nuevo León, from the Mexican National Technology Campus, and the teacher of this assignment is Luis Alejandro Reynoso Guajardo. I'm going through the I'm going through the grade of Ingeniería en Sistemas Computacionales in December 16, 2022 from the materia Lenguajes y Autómatas. Today I'm going to explain the Turing Machines unit project that will be Java NetBeans lexical analysis. During the index, we can see the number of the subteam Turing Machines Java NetBeans lexical analyzer project. The index, the lexical analyzer made in NetBeans, the program, the screenshot of the lexical analyzer, the source codes, and executables, the conclusion, and the reference. And for an introduction, I thought that through lexical analysis we have realized how important the correct syntax and semantics are in the language, and for any type of automata, serving as a fundamental tool to create this program of algorithm and to be able to generate more and more process efficiency. And for the same reason, we will be able to create a program that generates just that, a lexical analyzer. And to be able to do that and understand it in the background. We start here with a bit of theory. We can say that the lexical analysis was created through the Java programming language and executed to the NetBeans Integrated Development Environment (ED) that will give us more flexibility when programming an efficient way of compiling everything. The description of the lexical operation, also called token. A lexicon is understood as the set of known words of a language, that is, its vocabulary, which is included in the dictionaries of that language. It is a set of words and associated meanings, which means that whatever works at different levels, that of a formal language. The next point of this project is describing the advantages and disadvantages of having a lexical analyzer. First, for the lexical analysis advantages, we can say that the design is simplified, since there's a tool specialized in the treatment of that file that contains the source code. That the second point is that increases the portability of the compiler, being able to put different versions for different formats in different source codes, as the A, B, C, D, E, C. The third point is that it improves efficiency, as it is a tool specialized in the treatment of characters. And the fourth is the detection of certain errors that are easy to correct at this level. As I said, uh, a very small disadvantage that I can notice is the dependence on the tool in the cost of reading. We can having this example of how it works and lexical analysis. Well, it's only in Spanish, but we have the problem where a source code the lexical analysis interprets it goes to the token where the syntactic analysis will either ask the next token or give a table of symbols so it can create an automata with which we have seen in past units of this material, which is lenguajes y autómatas. So we next up the theory. We have various array of various concepts to explain, which it first the pattern that this is a rule that generates the question of characters that can represent a certain lexical component, a regular expression. A lexeme, which is a string of characters that matches a pattern that describes a lexical component. A lexical component can have one or infinite lexemes. For example, reserved word would have a single lexeme. Numbers and identifiers or IDs have infinite lexical components. The development of the project, that which includes the definition of the lexical components, the patterns and lexemes of the language that they can previously define as a team of the project which we are making the lexical analysis, which we need to identify the identifiers or IDs, constant operation, symbols, reserved words, etc. First up, to make the lexical analysis, we have the option to either choose CC or Java. In this case, we chose Java for its various advantages, but we will be able to explain a little bit of CC, which includes Flex as a tool for building lexical analysis. That it says that Flex takes an input of set token descriptions and generates the C function WWELex, which makes an lexical analysis that recognizes those tokens, which tokens are described by patterns that are extension or regular expression. Where we are to see this in the previous mentioned theory. And the basic programming language is C. Next for Java, and this is the programming language which we are recruiting with the ID NetBeans. We have chosen GFlex, a complement which we will be using as a .jar file, and Coop are tools that reflect on that react to a data input with predetermined structure and language, which are previously explored in order to work with the input data. In this way, it has been chosen to develop the project where we will use GFlex. Here for the program, we have the lexical component or tokens, which will be the reserved words, are reservadas, the, the operation of suma, resta, multiplicación, división, the thing of igual, the ID or identification as identificador, any number as number, and any error as the error. For the patterns, we can add the first import the java.io file. We have to take the main class and import it as the NetBeans projects as an Azure lexicon from source código lexer.flex will be at a root that will generate some better quality in the image that will bring us to using a keyframe for viewing the lexical analyzers. And it's the same, the public static void, general lexer, file archivo, new file, ruta, gflex.main.generate archivo, which will be able to say now all the main tokens are and lexemas are interpreted in this way. As you can see, while lexem return observadas, the slide signs as ignore, the equals as igual, the plus sign suma, the minus sign resta, the dot as return multiplication, the slash all slash are division, the this LLD as identificadores y DD más as return número, return error. We see the screenshots of the lexical analyzers, the shortcodes, and the executables. First, we have the project, and for 5 files with one JFrame, .flex file, and 3 Java classes we will be able to show next. But before that, we import a library that is called gflex, which I mentioned previously as if gflex.jar using the GDU key 1.8 as the default. We see the keyframe, we see the lexer.flex code, we see all the code and it's making the process. The main class that will be making our patterns are now making our main class. The tokens or shown here as reservadas igual, suma, resta, multiplicación, división, identificador, número y error. And the running program, we can, if we introduce any of these, it will show us what it is if we introduce an if it will show that it's a reserved word and it will show fine end. If we show the number 99, it will obviously show that it is a number. If we type the the word computer or computadora, it will show that it is an identifier or identificador. And if we mix these two, the analyzer is able to even show what each are that 99 if will be first the number and then the reserve word. For my conclusion of the project, I can say that through this project and the application of the lexical analysis focuses on Java, and more especially in the NetBeans editor, we were able to see all the lexical components, patterns, and lexemes. We're able to test them with a program that will identify and analyze the characters that we enter as way to give us the operation, the tokens, the identifier, and all the data which you have entered. In carrying out the project, it helped me a lot to little by little learn more about the automatas and be able to put it to use to the knowledge I had in this matter and in this class. These are my reference and to finish the project, I will be testing the program in the NetBeans ID 8.12. It's, it's taking a while, but it will load and will be able to explain the program. Here we are the project source packages and we add this package that we have all of our files, three Java files, one .flex file, and a Java file that contains a GFrame and for the libraries. I use the gflex.jar library to make a connection and to develop the lexical analysis. We better show it or we make it. Here's the design, the keyframe. We will compile the program to show it run. If we introduce 99, it's a number. If we introduce int, it's a reserved word. Introduce computadora, it will show that it is an identifier. And if we mix these tests together, like 99, we have it is a number and it is a reserved word. Fine. For last, we have here the reference where we where I have taken the bibliographies to put it to my project. I'm Jared Guadalupe Rivera Barco, and this is my project. Thank you very much for listening.